So next, let's take a look at a more complicated example. What I have here is a parametric profile which is defined in Grasshopper. So as you can see, if I change the parameters here, it will update the shape of the profile. And this is actually not just one profile, but rather it's a set of cross-sections that will be used along the road line to define the geometry of the bridge deck. So I can have variable parameters along the road line as well. In this example, I can vary the bottom level of the profile to generate arcs along the road line. So now what we need to do is to define a road line, and we'll just reuse the one we had in the previous example. And then the script here will generate the bridge deck, as you can see here in Rhino. And let's bring that geometry over to Tekla structures again. I'll just remove some noise here. And we are doing something very similar to the previous example. We are just extruding the profile along the line, then separately we extrude the whole and combine those two to generate the deck that we have here in Tekla structures. And in addition to the geometry of the actual deck, we can also insert all kinds of objects along the line using the points defined by the profile. So for example, here I have the bottom center points, and I can use those to insert piers at the support locations. And again, these are parametric, so I can change the shape and size of them from within Grasshopper. We can also insert, for example, some kind of railing, maybe some street lights. And this is all parametric. We can change the shape of it, the offset from the edges, the material, the class, and so on, all from within Grasshopper. And as soon as we need to do some modifications to the profile, for example, everything will adapt. So here, if I change the width of the profile, you can see how it moves the railing to the sides as well. Same thing if I need to move the road line, it will move all geometry at the same time. And as in the previous example, the road line doesn't need to come from Rhino. So let's bring it in from an Excel sheet instead. So the line that we have here, you see, is this self-intersecting line. Let's see what happens when we use that. You see how it here creates some kind of bridge ramp system which goes underneath itself, no problem at all. And the geometry follows, all the objects follow along the geometry nicely. And maybe because we have longer spans here, we need to insert some more support piers and generate some more arcs. We can just do that by changing a parameter. And of course, this is just an example. You can make the geometry as accurate as you want in terms of span lengths and so on. And even if I didn't show you exactly how the profile is created from the parameters, you can use the same basic technique to make any kind of complex profile with varying cross sections along the road line. So hopefully this gives you some ideas of what can be done in terms of complex concrete bridge geometry in Tekla Structures 2017 using the Tekla Grasshopper link.